yes, the old Ferris wheel problem. It has a radius of 30 meters and rotates completely every 100 seconds. The bottom of the wheel is located 2 meters above the ground. Create a sinusoidal equation, h of t, to represent the height h in meters of a passenger as a function of time t in seconds, assuming the passenger boards at its lowest point. All right, so what do I know? I know I have a Ferris wheel. There it is. I know that I have a radius of 30. Now, fun fact, whenever you're dealing with the sinusoidal function and the example that they give you is a circle, the radius is always the amplitude. Okay, so that's number one that I know. I know if I were to graph this out, I know my amplitude is 30. So I like to make a rough graph. Not that it's necessary for this, but I always like to make a rough one anyway. So I know that the amplitude is 30. Great. It rotates completely every 100 seconds. That, boys and girls, is the period. So over here, I'm going to have 100 seconds. The bottom of the wheel is located at 2 meters. Okay. 30 meters is the radius. So at the very middle of everything, if this is 2, at the very middle of everything, we're at 32 because, 2 plus 30 is 32. And at the very top of everything, we're at 62 because 32 plus 30 is 62. So 2, 32, 62. We start at the bottom, just like Drake, and then we make our way up and come back down with that perfect picture right there. Now, what do we know? Well, again, we know that the amplitude is 30. So if I were to start building a trig function, I know it's going to be 30 times, sine, cosine, we'll figure it out. Okay. The period is 100 seconds. So when I'm building an equation, I don't really care about the period. I care about the frequency. And the frequency is 2 pi over the period. So 2 pi over 100 simplifies out to pi over 50. So what I have so far is pi over 50. Now my options start to slim down a little bit. You're not pi over 50. And you're not pi over 50. You're upside down. So it's not A or B. Okay. Now, I'm looking at this, and it's like, one of these is wrong, and you're clearly the one that's wrong. But why is it C? And why is it negative? Well, if we look at this, if you're thinking it's cosine, technically you're wrong. Cosine starts up at 1. If you make cosine negative, you flip this over the x-axis. So a negative cos graph looks like this, which is what we have here. So we have a negative cosine graph. Okay, so I could just get rid of all this. That's just sloppy. Negative cosine, so negative 30 cosine. If I'm starting at the bottom and I know it's negative cosine, I have no horizontal shift, so I'm not going to have anything added or subtracted to t. So that remains pi over 50t. And if you're wondering, well, wait, where do these numbers come from? 32 is the midline. You always add the midline to the very end here. So my equation is h of t equals negative 30, because again, it's negative cosine. It starts at the bottom. Why is it 30? Because the amplitude's 30. Pi over 50. Why is it pi over 50? Well, the period was 100, and the frequency can be found by doing 2 pi over 100, pi over 50. T is attached. No horizontal shift because we're starting with negative cosine, and none of these display horizontal shifts, so I'm not going to try to force anything. And why is that plus 32? Well, you always add the midline on the outside of the function. So that's our guy, and that's our guy. I hope this helps.